Okay, well, thank you for being here. Our presentation is from myself, so Marcial Garbanzo, and Diego Souza. We are both co-chairs of the Satellite Data Requirements Group for the Americas. And hopefully you will know more about the group and what we do and how we do it at the end of the presentation. So we're going to start with the regional survey that took place this year. And this is a survey that took place all the way from Canada to Argentina. So it's a representation of what's happening in the Americas. The idea of this survey was to gather information about, data access, data processing, visualization, use and applications, and education and training. Because we do this in two ways, the formal approach and the informal approach. So in the formal approach, we send letters to the PRs, and PRs can review and reply whenever they want, if they do. And we have the informal approach, the permanent representative. Each country has one for WMO. And we have the informal approach, where we just contact, engage dynamic people in the region, and we ask them to contribute. So at the end, we managed to get over 250 replies for the survey, which is our largest number yet, which is good. As you can see the distribution there, so the Brazil and the US, they contributed most of it, but then there's Mexico, Canada, Chile, Peru, Costa Rica, Colombia, and then some other countries with less numbers there. But it's a good representation of what's happening in the region. An important thing that we do is we look into who is completing the survey in what way. So you can see in these graphs here, the institutions they belong to and who they're representing during this survey. So you get the idea if this person is representing itself or an institution or a country, which is good to know. Here we have some of the keywords that we managed to get from them about their institutions, their organizations. You can see Spanish, English, and Portuguese mostly, because that's the majority of the replies that we got. But then let's talk about RGBs. So we had 3 questions regarding specifically RGBs in this survey. 11 and 12 were the utilization of the geo and LEO data. So if you look into the questions, RGBs are second, first are individual bands, and then derived products. This is about utilization. So as you can see in the utilization, daily is in blue, then weekly, seasonally, special events in yellow, and not used in blue. So for LEO, for example, the not used is a large one for RGBs, almost as big as the daily use. So it's something to pay attention to. And we're already having conclusions out of this survey and taking actions towards, improving utilization of LEO, for example, and training. And training is actually the next topic. But first, let's look at this, because here you get a sense of what they're using the most. And as you can see, individual bands are a big part of the utilization of GEO and LEO. Also, RGBs, but probably not as popular. Regarding training, the RGBs are right in the middle. So in this section here, you can see the training aspect of RGBs. And in these colors, blue is basic training completed, orange needed, gray is advanced training completed, and the yellow is advanced training needed. So that's the largest one. So this is representing that we have trained people in the basic utilization of RGBs, but not advanced utilization of RGBs. So this is a very important aspect of this survey. So we have done some work. We have been training them for years, as Diego will mention in a second. And the training they got, they are considering basic training. So we need to move into more advanced training for RGBs in the region. These are some of the conclusions from the survey regarding specifically RGBs. So you can read them out loud. So you can read them, so I'm not going to read them out loud. Diego, would you like to take over?
Yes, can you still hear me?
Yep.
Okay, so first of all, thank you very much for the opportunity to attend this meeting remotely and for the invitation. Now let's talk about the importance of data access in order to increase the usage of RGB composites by the community. If users are able to access the NetCDFs, for example, and process them with reduced latency, they will be encouraged to produce their own regional RGBs. So we had several capacity building events on the last couple of years, and data access has been covered extensively. And here's an important detail. Data access might be something simple or trivial for some countries, but based on the community feedback, it might be a huge, big challenge for some countries. So it's important to train users on the available mechanisms on what they can produce with the data sets that are available in each option. So here on this slide, we have listed some of the recent events where data access has been covered, for example, for users in Brazil, Costa Rica, Ecuador, Colombia, Chile, and other countries in the WMO Regional Associations 3 and 4. Next slide.
Diego, just a quick comment.
Okay.
Some of these trainings, they have the title in English, but the training was in Spanish, and some of them have it in Spanish, but it was in Portuguese. So we do Portuñol and Spanglish trainings.
Okay, and during these training sessions, it's presented the characteristics of different data access mechanisms like direct readout and rebroadcast systems like GRB, HREAD NWIN, HRD, and GeoNetcast. Also, the options that are available using the internet, like the Amazon Web Services and the Unidata Internet Data Distribution. Also, the archive options like NOAA Class and UMETSAT Data Center, and an overview of some of the web pages that are available. For each option, we briefly show the associated costs, the latencies, the internet bandwidth required, and the available data sets. Next. Also, we show the pros and cons for each receive mechanisms, which is also very important for users to understand the advantages and disadvantages for each one. For example, for the GOES-R GRB, GRB stations, they have the highest availability and lowest latency for GOES level 1B data. However, to generate level 2 products, users need further processing and powerful workstations, and so on. So it's important for them to understand these differences between these data access mechanisms. Next one. Another very important aspect covered is the latency. How much time after the end of the satellite scan users could have the image available for their downstream users? That's very important because if users may generate an image faster than the visualization options that are available online, that will benefit them. So in this example from the Argentinian Air Force, a NetCDF file from GOES 16, it was a scan from 1510 to 1520 UTC. That is a full disk scan, a 10-minute full disk scan. It was available approximately 40 seconds after the end of the scan, and they took 4 seconds to process this NetCDF and generate an image for their service. And when they compared this latency to the delay of the imagery available on the web, for example, they are 1 or 2 scans ahead, which is good. And that is understandable because usually the interfaces available on the web, they are providing images for the whole footprint and in multiple resolutions, which takes some time. If users only need to process an image for a particular region, they will likely have the image available faster than the online options. Next slide. And apart from that, it's important for users to understand where they can access these NetCDFs. So for example, in a GRB station, we have 3 workstations usually: the data acquisition, the data processing, and the visualization workstation. So if they would like to process level 1B data, they need to access the data acquisition workstation. But if they want to process the level 2 data, they need to access the data processing workstation. This seems to be basic, but some users in the region had problems finding the directories they needed to look in order to access the data sets so they can produce RGBs by themselves. Next slide. And once they have that knowledge, we proceed showing the benefits of custom data processing, like on this example from El Salvador. They are producing these RGBs for a very small region. This is a 3 or 5 degrees approximately, and they have, you know, custom maps, custom labels, custom legends, according to what have been requested by their managers. And they are also producing these RGBs very fast with an optimized latency. Next one. And here we have a very nice example, another example of customization where a user is overlapping the NHC tracking and forecast with the true color RGB. And they are doing the download and processing also with Python. So this is the kind of ability these trainings are aiming to. Next one. Now let's talk about the training approaches used during these capacity building events. Next. Basically, we provide procedures and tutorials so the participants can execute scripts either locally or directly in the cloud using, for example, Google Colab. Using Google Colab is easier because they do not have to install anything in their machines, so they go directly into the details of the commands that are being used. And once they have access to these scripts and are able to execute them, we explain script by script in detail, starting with basic plots and increasing the complexity little by little, like in this example, from basic plots to titles, legends, maps, shapefiles, overlay with ABI with GLM, exemplify the creation of RGBs, how to create custom color tables, regional plots, which are very important to reduce processing time. Next slide.
Diego, just a quick comment that
Okay.
Just to clarify that using the Colab Research application, it's great for training because it lifts the burden from the user of bandwidth and computer power. So whatever computer they have, they can use for the training if we're using the Colab Research, which is great. It was crucial for the trainings during the pandemic, and we're definitely going to keep using it in future trainings.
Exactly, and I would like to thank Marcial for that, because before he introduced Colab in the trainings, we only used local data processing, and some users had problems installing these softwares, and now we have both options available. And we also covered some more advanced features like reprojection, processing, and accumulation of level 2 data. Next one. Specifically talking about RGBs, one of the approaches used is to begin the training session exemplifying the creation of a 3D color matrix with Python, where each element of this matrix is a contribution for the R, G, and B components. And trainees, they can change each element and test the results of different color contributions. So for example, if they set the maximum contribution for the red and green, they will get yellow. If they set the maximum contribution for the red and blue, they will get magenta, and so on. So after testing different contributions and assimilating the concepts of RGBs, we do the same thing, but using Gold 16 bands. Next one.
Just a quick comment that
Okay.
This is the material from my courses at the University of Costa Rica during the meteorological instruments course when we see RGB. So this is the code that we use, and these are the examples that we have.
Mm-hmm. And after these training sessions where they executed basic processing and RGB scripts, we propose some homework activities also using Google Colab, where 3 code examples are provided apart from all the others that we have already provided. One with the split window channel difference and the other 2 with the RMS and default phase distinction RGBs. Next one. So they copy these example scripts and adapt them according to the recipes, and which are also provided in Google Colab. So we start the activity proposing the creation of 4 channel differences, and the changes they need to make are very small changes, so they do not have much trouble trying it, and we also suggest what these changes are. Next slide. And on the last day of training, during the homework reflection, we review these changes and answer their questions. So they have an example. For example, here you have an example of the night fog difference. Next one. Another example for the split cloud phase. Next one. Split water vapor. Next one. And an example for the split ozone difference. So as you may see, they just need to change a few lines of code. And after that, next one. And after these 4 channel differences, which are simple, the scripts are more simple. After that, we propose the creation of 4 RGBs using the example Python scripts as a reference, so they can copy, paste, and adapt the existing script. Next one. And again, on the last day of training, during the homework reflection, we review the necessary changes on the code. To facilitate things, we separate the code into coding blocks for the most important steps, like you're seeing here, like downloading the files, reading of the matrices, the RGB components, recipe, minimums and maximums, gamma corrections, and normalization, and the stacking of these components to actually create the RGB. So here you have an example of the dust RGB, here one for the SO2 RGB, next one for the night microphysics RGB, and the last one for the day land cloud RGB. So next one. And between the first and the last day of this specific training, we collected the frequently asked questions that the attendee sent by email, and we also review these frequently asked questions. And usually the errors are small things like the values of the gamma corrections and so on. Next one. But all of that was done through Python, using Python. We also have used graphical user interfaces in the past, and here's an example of SIFT, which was created by the University of Wisconsin, and it is great. From the graphical options that I am aware of, I believe this is the easier and the most intuitive one. The only minor detail is that the definition of gamma in the quick guides that are available on the RGB web pages, the gamma is the denominator. But on SIFT, the gamma is the result of 1 over gamma. We struggled a little bit with that, but after, thankfully, we got a quick clarification on the SIFT GitHub page, but the software is very good. Next one. I think Marcial has used SIFT in the past, right, Marcial, in your classes too?
Yeah, it's the first approach to satellite imagery. We do it with SIFT. Yeah.
And apart from SIFT, we have used other graphical interfaces in the past for training on RGBs, like Makaida's V, and we also had good results. However, using different tools in different trainings for different satellites really makes it difficult to go beyond the basics, because you always have to cover the specificities of that particular tool. And so in the end, we are mostly using Python because the number of Python libraries are so great, and the varieties of satellites that we have managed to process with it is so nice. You can use Python to process GOES, JPSS, Meteosat, METOP, and many other satellites, and also NWP data. So using a single tool across different trainings, it really helps. Next one.
So for the next step, we have visualization examples of what we do. So we have tools that are using Python underneath to create products, and having many of them like Showcast. Showcast is used in Brazil, and it's a very good tool. It can be combined with the GeoNetcast to create a visualization front end for the GeoNetcast. And Diego is behind this tool. I don't know if you would like to comment something, Diego.
No, I just would like to comment that providing scripts and training on data access and processing is important, but there are some users and institutions that even if they know how to process and generate RGBs, for example, they have difficulty to publish the imagery in a custom web page. So that's when this solution is useful, as it provides, apart from the scripts and tools, it also provides a basic web structure that could be incorporated in their web pages. So that's the idea.
Okay, thanks. And in this slide, you can see examples of many med services in the region that are using RGBs in their websites. Different products, some of them are tuned to their needs, which is great. And we, from the satellite data requirements, we make sure that they communicate and get collaborations going. And finally, for the translations, we have lots of countries, but many of them speak Spanish, and there is Brazil with Portuguese, and the other part, the North American part, is mostly English. So when you look into the translation, those three languages are a major concern. We have quick guides in Spanish. For example, these ones are from Meteo Chile, so they're in Spanish. These ones are from the University of Costa Rica. One of the big complaints that we always got with the quick guides that we get from the US is the region that is shown. So in these ones, in the Costa Rica case, Costa Rica is in some of them, then Nicaragua and others, El Salvador, Honduras, Guatemala, Panama. So it's a first step to get them to read them. They see themselves in the quick guides, so it's good. We also collaborate with NOAA. For example, this one came from Eric Madsen. He had a presentation for GoSR and asked the SDR group to translate it. So we translated them into Portuguese and Spanish as a collaboration with NOAA. Diego, would you like to comment about the GeoNetcast Americas?
Oh yeah, just a quick comment that we organize quarterly webinars for the GeoNetcast Americas community. And just would like to mention that on recent webinars, one of the strategies that we have been following is that, sharing all the presentation files already translated to Spanish and Portuguese, so the participants may follow these translated documents during the webinar. And the feedback was very, very positive, because before that, we tried to translate everything, for example, we have the presenter speaking in English, and then we translated everything to Spanish, and then everything to Portuguese, but that took so much time. So we changed our plans, and now we are providing the presentations already translated for users, and the feedback was very good.
Thanks. We also have many of the comment modules already translated into Spanish and Portuguese. Of course, we would love to see more of those. And we have collaborated from different centers of excellence and universities in our region to these translations in the past. And we're willing to keep doing it in the future, of course. And this is something about what I was saying about translation. So if you look into the languages that we speak in the Americas, it's mostly English, Spanish, and Portuguese, with some French and Dutch in the Caribbean mainly. But then those 4 bullet points at the end are probably the most important ones for us. Some of these topics were discussed in VLMG 10 about translation, for example, the formats that we use for the documents. Some of them facilitate translation and some of them do not. Real-time translation during the teleconferences is still a need. So we have, for example, a few weeks ago, we had the first GeoXO teleconference. So NOAA was presenting what's going to happen and how it's going to happen and getting feedback from the members of this SDR group. But we did it in English. So there were lots of participants from South America and Central America that, I could translate some of it real time in the chat, but it's not the same thing. Also, the availability of trainers that are fluent in all the things that are needed, right? So the language is the first one, but then you need the technical and the professional abilities of, if you're working in GRBs or RGBs or whatever you're working on, they need to know about those things as well as the language. So yeah, I think that's probably the end of it. So thank you.
Thank you.
Anybody want to make a question or a comment? Yeah, Ivan. Just a quick one on the 4-point-something seconds to process what exactly?
It was, correct me if I'm wrong, Diego, but I think it's the time it takes to, once you get the product, to have it on the website.
I mean,
Exactly.
okay, product meaning what?
The image.
One image. Okay.
Yeah, the RGB on the website.
Thank you.
It's pretty good.
So that's starting with the level 1B
Yeah.
inputs, processing those, reading them, and then making the image. Okay.
Yeah. No, this is something that Diego mentioned it because most of these products are tailored to the country that's generating them. So if it's Chile, it's going to be Chile. If it's El Salvador, it's going to be for El Salvador.
Yeah, and that's how they managed to get it so fast. Yeah.
Diego, this is Bernie, because I remember you mentioning something about, if the GRB, because we have some people here from Europe and Africa, where they don't have the GOES rebroadcast, which is essentially the level 1 data. And the data that goes through GeoNetcast Americas is level 2 data. So can you comment on some of the processing for creating things, or at least converting level 1 data to level 2 data for brightness temperature versus getting it through GeoNetcast?
Oh yeah, we have some repositories that is freely available and created by the community with code examples for converting the level 1Bs to level 2s. So if they have level 1Bs available, they can convert the radiances to brightness temperatures using a couple of functions without any problems. So yeah, we have worked with the community on that subject also in the past, and the code is freely available.
Okay, I'm remembering something about the amount of time it took to do a full disk image was, you could get the image through GeoNetcast just as quick as you could receive it through a GRB.
Oh yeah, for example, at INPE we have a GRB, and the level 1Bs, they are received, they are processed in a few seconds, right? They are received in a few seconds. However, we need to have the algorithms to generate the level 2s in the second workstation, which is the data processing workstation. And we usually get, some of the products after 10 minutes. However, in GeoNetcast Americas, NOAA is processing these level 2s. And the requirements, they can produce these level 2s in a second. So GeoNetcast Americas users receive the level 2s developed and created by NOAA faster than we can process these at INPE in our GRB station. So that's the pros and cons of each system, right?
Okay, thank you.
Thank you.
Just a quick comment that all the code that you saw, it's freely available, and we can share it with whoever needs it. So ask away. Okay.
Okay.
Thank you.
Thank you.